Guys, hope you're doing well. I'm just going to go ahead and do some practice problems for the second section of your homework or your assignment that's due tonight. So what I want you to do first when you see a piecewise function is to graph the lines. So graph the lines, pay no attention for now to the given domains. So for example, we have a problem right here where the line is mx plus b, so we know that our b is 4, meaning our y-intercept is at positive 4. And then we know that we are creating a line crossing at 4 that has a slope of negative 1. So that means that when I draw my line, I'm going to have it go up 1 and to the left 1, right? Because it's a negative slope. That means that if you were to go left to right on any function that has a negative slope, it would go down, right? That's your hint. And so just like I said earlier, ignore any kind of these domains. Let's just draw the lines out so we can tell what the shape is. Then you're going to do the same thing for this one. So notice how this one doesn't have a slope at all. That means it's a horizontal line, meaning that you just have a horizontal line that crosses the y-intercept at 1. So that's the first thing that you're going to do. Then you are going to look at the domain. The domain is like telling you where exactly the location of these lines are. So this domain tells you that x is between -5 and 1, meaning that this line can only exist between x -5 and +1. So that means I need to draw out my line a little bit more to -5, and it can't go past 1. It has to end at 1. So I'm going to actually, bring it down to 1. So that is how long that line should be. Then I want to look at what type of endpoints do I need. Since both of these endpoints are inclusive, meaning they're less than or equal to, I'm actually going to keep these circles as filled in. Moving on to the next line. So now for this next line, I see that my domain has to be between 1 and 4, meaning I have to cut this line short. We're bringing it all the way back to 1, and it'll go out to 4. And notice how these two are not inclusive. They don't include 1 and 4. So I'm going to click on each endpoint once to show that they would not actually be included. So that is all you are doing. So just to reiterate, you draw your lines, then you make sure they are in the right location, and then check their endpoints and make sure you're good. So you should get the right answer, fingers crossed. Yep. Now let's do one more example. I want one. Yes, perfect. So here's another example, 2 lines, just like you've been doing. So let's draw out those lines. So we have one at 3x plus 4, meaning our y-intercept is at 4, and our line has a rise over run of 3. So every time you go up 3, you go over 1. And I want this to go in both directions, just so I get a good idea of what this function is going to look like. Let me make sure I got that right. Yeah, okay, so then you're going to draw your second line. Your second line has no slope, there's just a y-intercept of 5, so it's going to go all the way across at 5. Then you are going to look at your domain. So this diagonal line, the 3x plus 4, is only true when x is less than -1. So you're actually going to bring that line down. 1, 2, 3, 1. Right, 1, 2, 3, 1. We're actually going to delete the rest of this line. Make sure I'm in the right place. So goodbye. We lost our other one. It's okay. I'll redraw it real quick. This happens. That's why I do suggest that you do graph it on your own paper and then just transfer that graph onto Delta Math, because Delta Math is pretty finicky, and apologize. I wish it was a better situation, but we do have to work with what we've got. So this one says that when x is less than or equal to -1. That means that this line exists for any value that's equal to -1 or less, right? But if we looked at this graph, this is only telling us that it's true until -3. So in order to make it true for all values less than -1, we have to make this an arrow. And there's your arrow. Now for the other one, it has a similar situation, right? This line is only true when x is greater than 3. So our domain actually starts here, and it keeps on going. On the left-hand side of this line, we need it to be an empty circle because it's a non-inclusive 3. So I made a mistake, but you would only click on it once for that to happen. And this function, for any value greater than 3, the y value will be 5. So that means that we're turning this into arrows. Notice that if there are no upper bounds on this piece, on the second piece, and any lower bounds on the first piece, then it will be an arrow. Because that is true, then it's saying that it's true for all values less than the value. I hope this helps. Let me know if you have any other questions.